What is going on YouTube? Welcome back to another video of 100 Days to Python Mastery. Just as a quick aside, there's a lot of, you'll see books or programs out there for, 24 hours or 1 hour to master Python in a day and all that kind of crap. And it's complete and utter bullshit. I can tell you the syntax of any language. It doesn't mean you know how to program in that language or code in it or code in general. All of coding is creative problem solving. It's creative writing in the sense of why we do this channel, to learn how to read code and write code. But you can't write excellent code unless you can read code. Because otherwise you get to someone else's code and you don't know what the hell they're doing. More importantly, why they did it. But you can reverse engineer things to an extent. But learning how to read the stuff is hugely important in learning how to write the code. And I don't want people to get disillusioned, because then you start this stuff and you're never going to finish it. And Peter, his last name escapes me. He's with Google. He was one of the big guys with NLP, which is neurolinguistic programming. Nope, kidding. That's for hypnosis work. But natural language processing. And he wrote a great article about 10,000 hours to becoming a great coder, or essentially going to 10 years to really becoming an excellent coder. So even with this 100 days to Python mastery, you're going to learn how to do a buttload of exercises to the point where you would kick ass on any interview that would be Python related or coding related, as long as you knew that particular language's syntax. And then in addition, because of things like interviews, people who do these online courses, they never take the time to learn the computer science aspect of it, which primary importance would be something like the algorithms, binary trees, bioanalytics in some places, business enterprise apps and so forth. And you need to understand those things. You don't have to implement them, but you have to know them and understand them and know how to speak to them. Otherwise, you're doing yourself a huge disservice. So because of that, that will be an additional segment of playlist that we put out with Cup of Code 01, so that you can just make yourself an all-around excellent candidate for any job that you want to do, but also have a deeper and better and more fundamental understanding as to what the heck it is we're doing with these electrons via electricity floating around our motherboard and chips, and what we're doing with binary code and so forth. So with that, let us begin. Day number 8. Now, like I promised, we're going to be doing a lot more coding today. So if I come here to the sidebar, we got a couple of different examples, 55 lines of code. I know I said 60 before, around 60, so I swear to God, if anybody's like, you said 60, we got 55, like, get a hobby. Anyway, let us begin. So I'm going to debug, go to my console. All right, first off, we got a variable, pets. Pets is a list, and it's got some elements in it already: dog, cat, bird, rabbit, fish, and neighbor. Neighbors are pets, in case you didn't know. Let's F8 through that. And of course, in memory, we create the class list, pets, with the variables that we put in. To get each item, now what I put here is I put a comment to get each item in the list. If I said, give me, pull out dog, pull out cat, pull out bird, you'd have to know the index position. So you'd have to know that cat's at an index of 1 and rabbit's at an index of 3. And if you want to do that, you could print pets and then call index of 0, pets, index of 1, pets, index of 2, and so forth. So we'll go through that, and you'll see on the right-hand side here we have dog, cat, bird, rabbit, fish, and neighbor, the most popular pet of all. But that's also time-consuming and tedious. So the smarter way would be the smarter way to call all of those elements if we wanted to print them out or do anything with it, which we'll get into more with pandas. But you would do that with a for loop. So now I have here on line 14, for doodly d in pets. Now, doodly d is not a Python function or method or class or instance or anything. My point of using stupid names here in words is to impress upon people that you can make up whatever you want. So when you see for I, for x, x for x in, it's that x, that y, that I, all of those things are chosen by the coder. So you could have had anything. So for doodly d in pets, print doodly d. So for all the individual elements in pets, and pets is a list, print it. So I'm going to F8 through it, and we'll F8 through the print function, and I get dog. Now we go to the next part, cat, and it's gonna iterate through each piece for each doodly d, and you can see it changes the variable. Each doodly d, it's going through true, 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 until we get to a false. So now we went through all of our lists, so then print doodly d was done. So essentially that's like being a false. So we go to the next line of code. And that is, I think I'm ending there with the pets. Yes. So play with that aspect there and then keep going. This was just an example to show that this is a very pain in the ass way to do it, and then you could utilize the for loop to get there a heck of a lot faster. And precision in code at this level of what we're doing means absolutely nothing. But when you get to a higher level of things, it's called big O notation. It does become a factor. It does become a factor. So yeah, computer programmers every day go through the big O. Now, next spot. Let me drag this down a little bit. So now we're going to rock out a conditional statement with a while loop. So I have a variable that I created called I got $20, and it equals, magically enough, input of 20. So we have the variable in memory and the input in memory. So now for the while loop that I created, it says while I got $20, while that bucket that I created with the input of 20 is less than 35, I want it to do something. So before I go any further, you and I know that that's true. 20 is less than 35, correct? Yeah, so it's true, so we can go to the next line of code. So we're going to F8 through there. So print, I got $20. So is 20 less than 35? Absolutely. So print, I got $20. So then it's going to do that. So we can see on the right-hand side under neighbor, it printed number 20. And that was true. So we go to the next line of code. I got $20 plus equals 1, which means the variable that we had for I got $20, we want it to be I got $20, which is 20 plus 1 more. So now it's going to change the variable in memory from 20 to 21. So we go and we keep hitting the wrong function key. Now it's 21. You can see I got $20 now equals 21, even though the original input was 20 because we added the 1. Now we go back to the while loop. While I got $20 is less than 35. 21 is less than 35. True. Print I got $20. Now we're going to get 21 on the output. True. I got $20 equals 21 plus 1 is 22. True. So we're going to go back to our while loop because we're still within that loop because we haven't gotten a false yet. We haven't gotten kicked out of the loop. So now you can see the input is 22. So I'm just going to go through this 24, 5, 6, 7, 8, 9, 30, 31, 32, 33, 34. Now 34 is less than 35. Yes. When I get to 35, 35 is not less than 35. So we're going to go down to the next executable code outside of that loop, which is the print function here because of indentation. So it's going to print, I need more money. And yes, we had more. We had 35. Now we want more. We want 20. That's how it works in this world. We want more money, always. So now, okay, we're done with that section. And I have here, never forget that an infinite loop equals the never hits a false statement. Meaning, let's say, how do I want to do it? Yeah, let's do it. What the hell? Do I have an example below? No, not on this one. I think I did it later. Let's do it here. Let's take, I'll show you on a different file. Let me copy this. Let me go to here and I'll just write test. I'll put you down. No. So we got this. So what I'm going to do is I'm going to bring this up because I want you to see this. And I want to run test. So we ran it. Same thing we got before, nothing special. But I'm going to put, well, it's greater than 35, and we're going to make this 40. Now, the reason that that's important is what's going to happen with this code. While I got $20 is greater than 35, which it is, it's 40. And then it's going to do I got $20, and then it's going to do plus 1. So it's going to go 41, 42, 43. It's never going to be less than 35. Never. It won't even be 35. It's always going to increase. So what that's going to do when I run this, watch the output, it's never going to stop. The condition is always going to be true. The while loop is constantly true. It's always true. So it's going to keep doing this. Now this is how computers will crash or freeze up sometimes. It's because they're stuck within a loop. It's like, a brain freeze kind of moment for you. Now in PyCharm, the way you can stop this is by hitting the red stop button there, and then we finished our process. If you were doing this in console or other developer environments, you might have to hit Control C. Control C will kill the code that you're running. So I just want to do that for showing purposes, how you could really piss somebody off, because something else we're going to be doing at one point is we're going to create a program, like a reminder program, that will run in the background, and then at a certain time interval, let's say every 30 minutes or every hour, whatever you want it to do, it's going to pop up with a website that's going to, if it's a YouTube site, it'll play the video, or if it's a music site, it'll play the music, whatever it's going to be, as a way to remind someone to take a break. But you could also conversely have a program execute a certain time period, a continual loop that would crash their system. Kind of screwed up, but you could do it. All right, so let me get out of test, and I want number 8. So let me clear this out. Clear all. Good. So let's get back up here. Let me bring this window down. I don't need that much. We did the doodly-dee neighbor. Neighbors are pets. We did money, and we did our infinite code. All right, so I'm going to bring you down to here to run our debug. Did it. Could have commented all this out, but then it's going to look ugly because then everything would be green, and that would just piss me off. So you can see here what I did. I will quickly comment this out, and then I'm going to delete it because I don't want to screw up my system. But this is another example of a loop that would continually run. It would never stop. So x equals 5 while x is greater than 3, always going to be true. Print, this was very dumb to run. So if you were to execute that in a file, it would just, every line, this is very dumb to run, this is very dumb to run. It would continually keep printing that. It's an infinite loop. So with while loops, which is a conditional loop, you want to be extra freaking careful that you're not screwing with it. The control / just to comment all of that out. Because again, you could crash your system or somebody else's system, but conditional loops can screw you over, but they're also extraordinarily useful. All right, so for all numbers between 1500 and 2700, which are divisible by 7 and multiples of 5? So you've seen this before. We did divisible by 7, not a multiple of 5. So then we had the modulo of 5 exclamation equals 0. So modulo of 5 not equaling 0. So that means we have a remainder. So it was not clean. So now we're just doing the opposite of that. So for I in range, should be quick for us. For I in range 1500, that's the first part of the range. If I modulo 7 equals 0, meaning it's a clean division, 35 divided by 7 is 5, there's no remainder, and the modulo 5 also has no remainder, then print I. So that's just going to run through, and we are not... Why do I keep picking these ridiculous ranges? It's asinine. We are not going through that step by step. Love you guys, but no, that's freaking ridiculous. So I'll go 1550. So we get 1519, we get some in the 20s, eyes going, let's rock and roll. We're going to get to 49, we're not going past 49, because again, it does not include the last value. So it is, oh crap, it still has the additional thing in memory. That's the whole point. My bad. And then we're out of that code. So out of 1500 to 1550, there are only 2 values that are both cleanly, meaning no remainder, divisible by 7 and 5. We got 1505 and 1540. So write a program that will guess a number between 1 and 10. So easy enough. So we're going to, first off, we're going to import a module called random. That's how we can have Python randomly pick a number for us, or a value. So we're going to F8 through that. Where are we? All right, so we import a random. Now I have 2 different variables. I'm not putting them on separate lines. I'm putting them on one line. You can do that separated by a comma. equals, then as long as you have it organized appropriately where the value is aligned appropriately with the variable that you have. So I have target num, comma, guess number equals random integer, so rand int 1 comma 10 comma 0. So what we're doing here is we're telling it, using the random function between the values of 1 and 10, pick a number. Pick any number. And then the guess number I have right now is 0. So this first portion, this random.randint 1 comma 10, is being applied to target num. And then guess num is being applied right now to 0. We have to give it a value to fill it. Now in our while loop, let's F8 through that, and we'll see our pieces. Target num 10, guess num 0. While target number is not equal to guess number. If the target number is 5 and the guess number is 5, you're done. You guess the damn number. But while target number is not equal to guess number, F8, we're going to guess the number. Guess number is an integer. We're asking for the input here. We're asking the user, guess a number between 1 and 10. Keep guessing until you are right. And then we're asking for the input, so they're going to input, and then we want it to be an integer. And then printing game over and it's not going to print game over, look where it is in terms of indentation, until that loop is complete, until that conditional while loop is complete. So I'm going to F8 through that, and it's going to ask me over here for a number. Get back here. And we're going to put 3, and I hit enter. So now I have guess number is 3. If you remember, the original was 0. But I know let's F8 through this. So it's telling me to guess again. You see how it printed here again? Nope, saying you're wrong. Guess a number. So I'm going to say 9. And now I have guess number is 9. Now we know what the target number is. Shh. Just because we're debugging. But normally you wouldn't know what the heck the target number is. But I'm going to F8 through this, and it's going to tell me, again, third time, keep guessing. And then I'll do 10. Now my target number equals guess number, and while target number does not equal guess number, run this. So now target number does equal guess number, so this becomes false. So it's going to go to the next executable line in the code, which is print game over. So I'll F8 it, so sure enough we get down here, game over. That's how you can do a program guess a number from 1 to 10. We're going to do a larger version of guess a number when we do some of the Python projects, and that one will have a number of different class structures built into it so that it will tell the person your guess was too low or your guess was too high. We'll make it a couple of more conditions, again, just for programming experience. Now, lastly, we have create a cool printed pattern that looks like a sideways triangle, if you will. This is kind of fun. This is, I particularly like this stuff because it takes me back to the 80s of DOS days. I remember my first computer was an IBM PC Junior. I think it had a whopping 512, was it kilobytes? I think it was 512 KB of memory back then. You open it up, your DOS screen, just like this green on the right with a couple of options. King's Quest, that was an awesome game back then. So let's go, let's get to it. So I have count equals 0, I have a variable equaling 0, for number in range of 7. So now this range is going to it's going to include that it's going to go from a index of 0 to an index of 6, which is actually 7 numbers, if you will. For numbers in range 7, count equals count plus 1. So let's F8 through that. So number equals 0, count equals count plus 1. So now count's going to go from 0 to 1, and we're telling it print a star times the count. So the count's 1, so it's going to print 1 star. So I can see in the right-hand column here, I printed 1 star. Now I'm going to be number 1, count equals 1 plus whatever the count is at that point, which is 1. So 1 plus 1 is 2. Now we're going to print 2 stars. Star times count. Star times 2 is 2 stars. And it's going to keep doing this. 3 stars, 4 stars, 5 stars. And you're going to see the count is always going to be 1 above the number because the range is only going to 7. So it's going to go to index of 6 but not included. So now we print it out. We have 1, 2, 3, 4, 5, 6, 7 stars, because again, index of 0 to 6 is actually 7 numbers. And we printed those out on the right-hand side. So that for loop is now met. For numbers in range 7, we've gone 0 to 6. We met that condition. So now when we did for position number 7 or index of 7, it's technically false. So we're going to jump out of that loop and go to the next executable line of code, which is for number in range 6. So now we're going to go index of 0, 1, 2, 3, 4, 5, 6. 0 to 5, which is actually 6 numbers. We're going to count. Now this is minus equals 1. So our count, if you look at the top, is 7. That variable is now 7. So now we're going to go 7, and then 6, then 5, then 4, then 3, then 2, then 1. And we're doing the same thing, printing the star times the count. So right now my count equals 7. It started as 7, so now we go through the code, count minus 1, 7 minus 1 is 6, print star times 6, so now we're going to get 6 stars. Now my count is still 6 until I go through this next line, which is 6 minus 1 is 5, and now it's going to print 5 stars. And we're going to keep going through this, 4, 3, for a number range, all the way down up to 6. Number range is 6, which brought me down to a count of just 1. And now we have our sideways triangle of stars. So getting into extraordinarily advanced graphical user interface using Python, as you can see. Which, if you like the whole graphical user interface, we'll be using Tkinter and some way more advanced Python GUIs and libraries, modules. And we'll have a whole different playlist just for that as well. So there you go. You got your number of different examples today, kind of jumping all over the place, which is what I like to do with Python. I want to make it this way. So then if you're doing this each day, then in a month from now, if I say, hey, generate me that, sideways triangle, you can start writing it. And even if I give you count equals 0 for num, your brain is automatically going to kick over. Oh, for number and range. What do I want to make? I want to make the highest star. 9 places, so I'm going to go range 10. And then I'll tell count is going to equal plus equals 1, and then print the star, and then it's going to be the value of count times count to get those number of stars. That's where memory is going to come into play as well, but it only gets better with the more you do it. So play along, have fun, and I will see you guys for day number 9 of 100 Days to Python Mastery.